I'm Clint Brown, and I've been at Esri a long time, and I'm up here with some really special people today. Three analysts that are some of the best in the world, frankly, at doing what they do, and we'll get into the presentation in just a few minutes. But we want to thank you for coming today. Basically, the idea of what we're going to do today is we're going to talk about approaches to spatial analysis, less about the specific technology, although we will demonstrate the use of insights of ArcGIS Pro. The goal today is to equip you with a few real simple processes, to give you a set of approaches that we think you apply over and over again every time you do spatial analysis. And I think for a lot of us, spatial analysis is one of the main reasons why we got into GIS and just the power of deriving new information and new insights, making new interpretations about information, making new discoveries is really important, and so we're very excited about the analytic capabilities in GIS. The idea that you can work with layers is really interesting. So analysis, really, if you start to think about it and you look it up in the dictionary, it's this detailed examination of elements or structures or things, often as a basis for understanding, for discussion, and also for action, as Jack talks about, understanding precedes action. And I think a key point that we don't want to get lost in us showing you technology and your focus on learning how to use ArcGIS technology are all these words, the things you do with your mind when you're doing analysis. And I think that's a key point that we'd like to emphasize in what you're doing. So I think every spatial analysis problem has two really interesting and commonly used workflows, and they repeat themselves over and over again in your work. The first is spatial data exploration. We're going to talk about how you interact with, explore, and begin to gain insight from your information. And then a second one is spatial problem solving. Every time you go to do an analysis, there's an approach or a kind of sequence of phases that we all go through for that. And I think these two approaches will give you a kind of pattern and a kind of framework that will help you do your spatial analysis. The first of these is spatial data exploration, and that's really interacting with and exploring your data. And as you know, there's not much you can do by opening up a spreadsheet or a table. That's not very useful. But the way people work with information is through maps and through graphs and charts and tables. But if you begin to think about how we all work with maps, part of the interesting thing about how we work with maps is they really enable you to explore your data. And I think one of the new capabilities that we have in this is smart mapping. So what's the first thing that happens when you create a layer? Just think about it for a minute, and I'm going to give you the answer, and it's kind of a cynical answer, but you don't touch it, because you don't know exactly how you got to that perfect layer that you're looking at. So you don't want to explore your data. You're afraid you can't get that layer back. That's really just the opposite of what we want to have happen as analysts, right? We want to explore the data, explore the distribution of information. That's where smart mapping plays a key role, this idea of becoming a data scientist and being intensely curious about the problems you're trying to address and the insights you're trying to gain. So that idea that smart mapping enables you to explore and interact with your data is really a very key point. And maps are very interesting because they provide it's one of those tools that humans use that provides an overwhelming amount of information, and somehow it makes sense of that information. Kind of the graphic display of maps are one of the ways that humans communicate. So that ability to interact with the map, to, if you make a map of a demographic variable, and the idea that you can start to explore the distribution of that variable or that statistic that you're calculating is very important. And then the idea that there's associated information with the map, that you can take graphs and charts and brush features in the map and see the observations in a chart, or select a particular category or time window in the chart and see your information in new ways. It's that ability to explore and to visualize the information, but also to use your head in that analytical process, that process of interpretation and discovery and so on is really key. So these two things combine, smart mapping and interactive mapping with interactive charting and graphing, and putting these together, marrying these, is really key. And I think this year we're showing insights, and we're also showing a number of new capabilities in ArcGIS Pro that really bring these two aspects of spatial data exploration to life: interactive mapping, interactive charting and graphing, and then the marriage of those two is really key. And I think one of the goals that I talk about a lot is, I think for a lot of you, if you're not already, we want you to become data scientists, right? It's one thing to be really conversant with our tools and to know how to operate the software. It's another level to reach that point where you can start to explore data, make wise decisions, have that kind of robust knowledge about how to do that. But I think first is to have the tools so you can actually learn by doing, learn through your own work to apply these. So that first approach is really simple. It's really learning how to interact with your data by putting our tools to work and ensuring that what we do is we build strong tools that enable you to interact with your data, to visualize it, and through that visualization to gain some understanding. The second key approach is something that I've just called spatial problem solving. And I think of it as what do we do when we want to compute with our data? What's an approach that all of us take? And what I've been thinking about is trying to describe this as a 5-step process. So the first thing that happens when you're trying to approach a problem is you pose a question. And as you pose that question, immediately a thing that's very useful to do is to actually explore your data. You really want to frame your problem and scope it and really understand it in a deeper way. And when you explore your data, you're applying that first approach that I talked about, that spatial data exploration is the first thing that you do to really frame the problem and frame the question that you want to answer. And there's a few examples here of identifying the best path for a wildlife corridor. On Monday you saw green infrastructure being presented, and there were some great examples of those kinds of questions. Sometimes you're looking at information, demographic information or expenditures of certain kinds, like what's the difference between Medicare expenditures across the country? That's a United States example. Global example, is there a pattern to the crime data by space or by time, by location or by time? So those questions can be asked in a general way, but then that spatial data exploration helps you to really dial in the problem that you're going to address and to help you decide what kind of spatial analytical operators you're going to apply to your information. The second step, and the one that frankly got me going in GIS and got me excited, is really modeling, computing with your data, building your own program, creating your own algorithm in a way. Our system contains a number of tools. Some are really straightforward single operator kinds of tools, like tools that you use to calculate some kind of spatial statistic. Others are individual operators that are really interesting. You basically feed your data into a tool. That tool runs an operation against that data and produces a new result. Well, one of the ideas behind that is it's not just individual tools that you run, it's this ability to string a set of tools together so you can feed the result of one tool into another. And by doing that, you can start to create your own model. And I think most of you in this room have had experience at doing that at some level. Sometimes people do it with Model Builder, some people do it with Python. In the future, people are going to do those same types of procedures with insights on the web. But that idea that you can create your own model of a particular problem is very interesting. And of course, that compute that you do is really in service of that original question that you scoped out and identified in step one. So the second step is to compute with your data. Third step, and this is one that I think up until now has kind of not gotten enough attention, I think, is explore and interpret. And this is the step where your mind goes into action. You work with the results of this model that you ran, or you work with the results of the statistical operation you just computed. And you might bring in other data layers in the background to understand that within the context of information. But that idea that you can begin to explore and interpret your data is really key. So you pose a question, you model it, and then you explore and interpret. And this is the step, I think, where a lot of the new tools are really important. That first workflow that I talked about, spatial data exploration, comes in again right here. That's the way you gain insight. That's the way you make interpretations. That helps you understand your problem. And then, with that result, there's really, you decide. You make a decision, you draw a conclusion of some kind, and then, very simply, you communicate and share your results. And again, in this fifth step, it's your opportunity to share that same spatial data exploration environment with the audience that you want to communicate with. Sometimes you're an advocate, right? You're advocating a particular position or a particular idea or goal. You want to present your information in an effective way, a way that has influence, right? And maps and charts and graphs are one of the ways to do that. So what's interesting about this process is spatial problem solving. This 5-step process really involves the application of spatial data exploration in 3 of those 5 steps. When you first pose your question, then you model it. Then what you do next is you explore and interpret right there, spatial data exploration. You decide, and then you communicate and share. Communicate and share, you also share spatial data exploration data sets, tools, and workbooks, projects with the audience that you're trying to reach. So what we're going to see today is we're going to see 2 examples from Flora Vale and Linda Beal. Both of these, what I'd like you to do while they're demonstrating the use of our software for these things, I'd really like you to just go back to those 2 workflows, these approaches. You'll see spatial data exploration in action, and along the way, these guys won't need to spell it out, but you'll see those 5 steps start to kind of pop up in your mind. Oh, I see what's going on here. So I just really want to use these two great examples. Well, there's more than two examples here, but two great presenters as a way to show these workflows, these approaches in action. So the first presenter is Flora Vale. She's a spatial analyst and one of our presenters in the plenary on Monday. And Flora works on the ArcGIS Pro team and is one of the engineers that's helping to design and build new spatial data exploration tools in ArcGIS Pro. So what number are you, 4?
I am 4.
Okay. Oh, you got your glasses.
Oh, actually, we're going to start with my 2 slides.
Oh, yeah.
All right, good morning, everyone. Do you guys remember this old meme? I'm just being silly here, but whenever somebody asks me what I do and I say spatial analysis, luckily I'm here at the Esri conference, so I don't think I really have to explain this to most of you, but the other day my mom was like, Flora, when people ask me what you do and when people want to know what my daughter does, I don't know how to explain it to them. And it can be a little bit difficult to explain. Often people, when I say I work in spatial analysis, they say like Google Maps or, like routing directions, or do you just draw maps all day? But really what I do is a lot of iterative analysis. I use lots of visualization tools to explore my data, and I use lots of our spatial analysis tools to quantify patterns in my data. And this is always an iterative process, like Clint said. I never run a tool just one time and have an answer. It's a lot of trial and error and exploration. And this morning I'm going to focus on some of our new charting capabilities in ArcGIS Pro as a means of exploring your data. And we have 4 chart types currently in ArcGIS Pro. We have histograms, which help us explore the distribution of our data in data space. We have scatter plots that help us quantify relationships between 2 variables. Bar charts that help us compare categories and amounts. And then we have line charts that help us explore change over a continuous range. So most of the time we're looking at change over time, but with spatial data we can also look at change over space. And so now I'll flip back over. So I'm going to start by taking a look at this data set that I got from cms.gov. It is a Medicare data set by county, and we have some different information here about the health of the population, the prevalence of some chronic conditions, and then the amount that we're spending per Medicare beneficiary in each of those counties. And so the first thing that I do when I get a data set like this is join it to a county layer and take a look at it on a map. And we have that map here. And so I want to understand the spatial distribution of some of these variables. So I'm actually going to employ some of our new smart mapping technology to take a look at the health of the population. I'm going to use the unclassed color render and take a look at average HCC score. So average HCC score is a measure of the health of a population. It's an index that's used to quantify the health of the population based on some chronic conditions like diabetes, asthma, heart disease, etc. So the counties in red are the least healthy, while the county in greens are the healthiest. And I can take a look here. Using the unclassed color render, I have a histogram looking at the distribution of these values, and I can interact with this while I explore my data. So I might want to account for some of these outliers and begin to see the spatial patterns emerge as I make changes in my classification scheme. So we do kind of see a spatial pattern here. We can see the distribution of these values over space, and we see that it looks like there is a pattern in space. We have healthier counties over here in the northwest and some less healthy counties down here in the southeast. And understanding the spatial pattern of this is very important, but we also need to understand the distribution of these values in data space. And so to do that, I'm going to take a look at a histogram of this data. So I'll point to my HCC scores and increase the number of bins here so I can get some more detail on the structure of my data. And so we see that it's actually a pretty normal distribution. The mean and median are the same, which means we have a normal distribution. But we do see a couple of outliers here on the far end. So if I highlight these in my histogram, I can identify where they fall on my map. And I can start to get some understanding of where these problems are occurring. I'm also really interested in the amount of money that we're spending per Medicare beneficiary. So I'm going to create another histogram to take a look at the distribution of per capita spending. And here we go. And so now if I highlight the counties that are spending the most, I see that in my distribution of HCC scores, those are kind of falling all over the place. So now I'm kind of curious, is there a relationship between the health of the population and how much we spend per beneficiary? Because in trying to understand why we spend more in some places than others, we might, common sense might say, well, maybe the people are sicker where we're spending more money. So to explore to see if there's any relationship between the two, I'm going to create a scatter plot. And compare that to my map here. So HCC score versus per capita costs. So we see that we do have a positive relationship. It's not an extremely strong relationship. And it's also really important to note here that when variables are correlated, it does not imply causality per se. This is just the first step in the data exploration process. So if I'm trying to model Medicare spending to understand what causes Medicare spending to be more in some places than others, I can't just look at a scatter plot and say, well, there's a positive relationship, so the health of the population is causing spending to be higher. But this is how I start to explore the different variables that might be causal to later put into a regression model or something like that. So again, I can interact with this chart and take a look at where we have those problem counties in the map. I also can look at local R-squared values. So here we get an R-squared value of 0.41, which would mean that the variation in the health of the population explains roughly 41% of the variation in per capita spending. We also have a tool in our regression analysis toolkit that called GWR. And again, looking at these R-squareds does not necessarily mean that one is causing the other. But when I make a local R-squared map here, I can see where those variables are most correlated over space. So it's a really interesting way of looking at it. I know that HCC score is most correlated with spending in these darker areas. And so if I'm beginning to explore what factors I might include in a regression model, I could focus on different areas differently, because as geographers, we know that geography matters and things vary over space. And so relationships in one area, what causes Medicare spending to be high in one area is not necessarily going to be what causes it to be high in different areas. So this allows us to target different locations differently and better use our resources, more efficiently allocate resources, because we understand that what causes things in one area might be different from another. I might also want to take a look at, summarize these counties by state and see how states are comparing to each other. And I can do that by creating a bar chart. So using this bar chart, I can summarize by state, and I'm going to take a look at the average HCC scores by state. I'll turn off my R-squared there. And so I can see here that DC has the highest average HCC score. And if I highlight the top few states here, we'll see those counties reflecting in the map. I mean, those counties belonging to each state reflecting in the map. And so these are the states with the highest HCC scores. And if I were to want to isolate those states, these selections are maintained they're honored when you run a geoprocessing tool. So I could use this selection as an input to a tool for a further analysis. So this is an example of a couple of ways that we can look at these data and start to understand the patterns that are interesting. Interesting things start to pop out. But looking at this map here, when I created this map, I adjusted that histogram, and I'll go back there for a second. I could slide this down here and make the problem look like it's a lot more severe than it really is, or it's not necessarily making it look like it's more severe, but as map makers, we know that there is some subjectivity involved in mapping. So just by sliding that down, now it looks like we have a really serious health problem everywhere. And so we also have some tools to quantify these spatial patterns. So the first step is making a choropleth map and kind of interacting with it through smart mapping is a great way of interacting with your choropleth map to have some spatial patterns start to pop out. But we can also employ some of our spatial stats tools to quantify these relationships. So I could run a hotspot analysis of this same data and look at where we have statistically significant clusters of high and low values. So the areas in red are statistically significant clusters of high values of HCC scores. And so I can be confident that these areas are not, these high values are not clustered randomly. There's something happening in this area that I need to explore further when I'm trying to understand what is causing HCC scores to be high or what would be causing Medicare spending to be high. To explore just one more relationship, as an example here with our county data, I'm going to create a scatter plot to compare two different of our chronic conditions. So we'll look at the percent of diabetes in each county versus the percent of hypertension. And so here we see that we have a slightly stronger relationship between these two. And with the symbology still maintained from my map, I get that third variable included in here. So the coloring is still by HCC score while I'm comparing diabetes and hypertension. And as we would expect, the higher HCC score values are falling where we have the most hypertension and diabetes prevalence. So as a way of looking at a multivariate data exploration. So next I want to switch gears a little bit and talk about some temporal data. So here I have some data about, these are crimes that happened in Washington, D.C. in 2015. And I want to understand how these crimes vary over space and also over time. Do we have any temporal patterns? Do we have any spatial patterns? So to begin exploring, I'm going to look at some temporal patterns by creating a line chart. And when using a line chart, if I point to a date field, I get some time aggregation options. And so what we're looking at here is each of these points on the line chart, they're actually a bin of time. And so the interval size, the default was 3 days. So for each of these, we're looking at how many crimes happened over those 3 days. So we're kind of binning this into this structure. I could increase this and maybe do 1 week and see a more coarse pattern. And as we might expect, we do see that crimes kind of dip in the winter time and we have higher crimes in the summertime. And I could also add an additional series to this to take a look at perhaps crimes by type. So I've split this into property crimes and violent crimes. And we do see that we have a lot more property crime than violent crime, so I think that's a great thing. We could also maybe look at this by ward to try to start understanding some of that spatial pattern. And here we have 8 different wards in Washington, D.C. And so this chart is a little bit busy. It's a little bit hard to look at. So I might change this to a 4-week aggregation scheme to clean this up a little bit and look at the broader trends. And so we see here that ward number 2 has the most crimes. while ward number 3 has the least. And again, these charts are dynamic, they're interactive, and they link to my map. And so it helps me pinpoint the areas in my map that are interesting to me. Another cool way of looking at this to explore this data is by using a range slider. And so I'm going to create a range here for my data. And I'm going to use ward as that range because I want to explore each ward one at a time. And with my range slider, let's see here. As I go from ward to ward, now I'm just looking at the chart for that specific ward. And I'm going to add an additional series here and look at the shift that these crimes happened in. So day, evening, and midnight crimes. And as I cycle through here, we can compare these different wards to each other and see how they vary over space. And so some of these areas have the most crime at night, while some of them have the most crime during the evening. And we can explore these and how they change over time also. So it looks like in this ward, we have more crimes during the day in the summer, while we have more crimes in the evening in those colder months. So a couple different ways of exploring this data, but we're also interested in this pattern over space. So I'm going to turn off my range here and take a look at these data and find some patterns over space. And so we actually have some, I could run a hotspot analysis on this data like I did with my Medicare data and just look at the patterns over space. But we do have some tools for running hotspot analysis over space and time. And this is called an emerging hotspot analysis. And so those areas in red are statistically significant clusters of high values, but we kind of, we look at this over time and we quantify the trends in those clusterings over time. And so a really a good way of understanding this is by comparing this to a 3D map. And so this is another way that data visualization helps us explore our data. The 3D map alone would not be enough for us to understand this pattern. And the 2D map really could use the 3D map to help us understand. So when we combine these different methods is when we get the most insights out of our data. And so in this map, the 2D map, we have some different categorizations of these hotspot trends. So for example, these areas here in the middle, these red areas, those are what we call intensifying hotspots. It means that that location has always been a hotspot, and the significance of that hotspot is getting hotter and hotter. And when we look at the 3D map, we can look at, so we bin this into these little time series bins over. So at the top, it's what happened most recently, and at the bottom, it's what happened most distant in time. And by examining these columns of data, we can see, oh, it makes sense now what an intensifying hotspot means, because I can see that, yes, it has been hot this whole time. And we can begin to understand those 2D patterns by using that 3D map in conjunction. And so with our 2 and 3D maps and with our different chart types, we can start to understand these patterns. And this is not the end. So data exploration is just the first step. It's the first step in any spatial analysis, is getting to know your data. And once you get to know your data, then you can really fine-tune your analysis question. Because it's really important to have a question when you go into an analysis. Just saying, I have some data, what's happening with my data? Well, lots of things are happening. Lots of things are happening anywhere. And we, as humans, we're really good at finding patterns even when they're not actually there. So it's important to get an understanding of your data and then refine your analysis question. So now that I understand that we have a big clustering of crimes in this area and that those crimes are intensifying over time, I might focus in on this area as I run my further analysis. So those are just a few of the first steps in the data exploration process. And I'll hand it back over to Clint.
Thank you. That was wonderful. What was really neat about that, and I don't know what was going through your mind, but what was going through my mind is, wow, the tools and the capabilities to do these workflows, to take these approaches of spatial data exploration and spatial problem solving are becoming quite powerful. And I was just thinking about the kinds of insights that we'll be able to create. You'll be able to really do some great work in the coming years. So next we'd like to have Linda Beal show insights. She's a data scientist and the instructor for the spatial analysis MOOC that's been going on for the past year, and pretty good person.
Thank you. Okay, hi. So I'm going to talk through an analysis that I've done recently. I was given a bit of a challenge. I was given a data set that was something a little bit different to something I would normally analyze. And I was asked to find an aha moment within this data. So could I find something in the data that people didn't know about? So, thanks. What you'll see when I talk, it's actually a completely different example. I'm using different software. Obviously, I'm still using ArcGIS, but I'm going to be showing it using Insights. But you will see a lot of overlap with what Flora's talked about, because ultimately, we're both doing analysis, and that's what we're all here to do. The tools that we use can change. I think everything I do, you could be doing it in Pro, you could be doing it in 10x, you could be doing it online. It really doesn't matter. What we're doing is talking through the thought processes and how we analyze our data and get that information out, find that aha moment as I was challenged to find. So I'll talk a little bit about Insights just because it's slightly new, but it's not about the software. So I'm going to start this workbook that I have here. So the data set I was given was from the White House Utility District. And what they do is they have a lot of calls about water leaks. And so they're in charge of all the water utilities across their area. It's a very large area that they deal with physically, so geographically they cover a large area. They have a lot of information that they're collecting. They have different departments that work with it. So they have the engineers who want their own information. They have the people who deal with customer calls, bringing that information in. And what they all work in slightly different ways of bringing in their data, but they want to try and see collectively what information they have in that. So that was my challenge to work with this data, and it's 10 years worth of data that I was given. So I'm going to add in my data that I was sent. So let's look at the number of lines that they have. And a lot of what we do within GIS is we're trying to get information by context. So it's not just understanding the actual data that you have. What we're often doing is compared to what? Because it doesn't really matter whether something's more or less, it's more or less compared to something else. And really that's where the geographic concept comes in, because we can say compared to this area or compared to the larger area. So I'm going to bring in some Excel data that's going to give me some information on the weather in that area. Because we're talking about water consumption, weather's going to have a huge impact on the amount of water consumption. It's also a very large data set that I was given. So some of it I loaded up into an SQL database. So I have the consumption data and I have the locations. So my Excel data, I can bring that straight in. Well, that doesn't really tell me a lot. Looking at the table, I can see the temperature and precipitation. But the first thing I can do is put that into a chart, and then I can see that pattern changing. So that's giving me some context. I'm seeing the overall pattern of it increasing in the summer, but I also see that some years have some slightly different patterns. So immediately I've got some information there that's saying, okay, on these years I'm expecting to see a slightly different pattern in the water usage. I can look at my data set online on the water main types, just to give me an idea of the different water mains. So again, spatially I'm seeing there are differences within that data. So I know that temporally and spatially I have different factors within that data that I want to look at. So I now have my locations that I could put on a map. So each one of these locations is where we have a customer. So these are all accounts, as they were. So down to the individual house, we have that information. Now, in terms of the locations, there's about 50,000 different individual accounts. But what they do is they're collecting that information every month for how much water usage they have for every year. So I've got 10 years worth of data and now 50,000 locations times 12 months. So yeah, I can map that. I can find an individual feature for each one of those, a lot of overlapping at each one of those locations, but it was slow. I mean, I was dealing with 5 million records. ArcGIS could handle it, which was quite impressive, but in terms of data exploration, you don't want to be sitting around waiting it for render, opening the table and waiting, and there's only so many cups of coffee that we can go away and make whilst it does it. So the sensible way of doing that is to use some kind of relationship with your data to relate those multiple fields to those single locations. So I can do that by taking my individual locations, taking my consumption. As I say, you can do this anywhere within ArcGIS, so it's just a relate. I'm just relating multiple fields back to the individual location based on the account number. So that's the individual feature that we have. Every person has an account that they collect that data for. So I can join that data, and now you'll see here we're treating that data set as one single data set. So now I have my locations attributed to each one of these amounts of consumption. And now I can see that amount of consumption by each one of these individuals. Let's just put it in a table. So you'll see that's the finest grain of information we can have it at. So automatically this table is summing up the amount of consumption. So rather than me seeing the data table for each one of these, it's saying for each account, this is the total amount of consumption that they have at each one of those locations. So I can start to understand the individual accounts. I can change that to the average, so I can say, which one of these accounts, which one of these locations is using more. But I can also kind of drill down into this information, so I could look at it by the metered areas. So within each one of these water districts, they have areas in which they meter the total amount of water that goes into that area and the total that comes out. So they have an idea of the consumption within that area. So just by changing that variable, I now have a whole new set of information dynamically calculated for me. So this is just getting the summary statistics for each one of these areas. I could also be doing that for zip code. So you'll see each time that's updating the amount of information that I'm getting. So now I'm understanding by location how much they're consuming, either in total or in average at each one of these locations. So let me have a look at the service requests. So I'm going to change over to another page, and I'm going to add in the service requests that have come in. So these service requests are phone calls that customers have made. So they phoned up and requested some kind of service. So they're either phoning up to say, could I have the water turned on at the house I've just moved into? I've got a leak in this area. So it's really about the number of phone calls that they've received and how they're dealing with the public. So the first thing they do when they receive this phone call is they prioritize it. So they decide how quickly an engineer needs to go if it's a leak, how quickly they need to go out and answer that leak. They also prioritize them by problem code. So what kind of problem is it that you have within that area? So let's look at it by priority. So I could put that on a map and see where these priorities are given. Well, we have a crazy amount of points in here. There's over 250,000 accounts that I'm looking at here. So yeah, I'm seeing a slight spatial distribution, but I'm not seeing an awful lot. What I could do is go into my spatial tools and I could calculate the density, which would much better show me those densities by each one of these locations. Or I could have a look at the priority by the number of days in which they respond to those on a chart. So now I'm seeing when the call is made, they prioritize that call, and then how quickly the engineer is sent out. The sum doesn't make much sense, but if I look at the average, we're now seeing them prioritized by 1 to 5, and I'm also seeing information about my data in here. So it's not just about the analysis that I'm pulling out. I also see that a lot of times they aren't giving a priority number to that call. So that's giving me information straight away. Does that mean that these calls aren't being prioritized? Are they being missed? Or is it just somebody not filling out the database? And why is somebody giving zeros to them? So that's giving me information about understanding the data as well as understanding the problem. So then moving on to understanding the problem, what I'm going to do is take those priorities and I'm going to filter out those values where they didn't make sense. So now I'm seeing the priority, and I'm seeing on average they're responding within 9 days to each one of these calls. I can also try and understand by the problem code what types of problems they have coming in. Again, I'm not seeing this on the map, but I can change the visualization and I can have a look at it as a bubble chart, for example. And now I can immediately see which type of calls they're getting, which ones are the most number of calls that they're getting. So we work visually very much in GIS, and there are lots of different visualizations we can use. One is never better than the other. It's often about a combination of things. It's often about working with things and linking it towards where it's happening. So I can pull out the information of where there are leaks within my data by selecting out, and now I see that pattern in comparison with sewer inspection. Now immediately me just clicking on the map, you're already seeing, okay, so leaks were everywhere, sewer is in one particular place on this map. So we can start to understand that data by using that combination of different visualizations between them. So I want to understand a little bit more about the leaks within my data. So let me go back to the map. And what I can do to understand those leaks is I can go into the problem code and I can filter out where we just have leaks within that data set. So again, at this point, I did actually have to ring up the engineers and say, what's the difference between a leak and a leak recording? So then they said, oh, that's an accident that we're collecting leak recording. They were in fact testing an automated phone call that when there was out of hours phone calls that somebody rang up, it would send out a message to say, yes, we've logged your phone call and we'll get back to you. But then of course it's being double counted because then they would count it as a leak. So that was interesting information to understand from them what was going in and what we were seeing within our data. So filtering out the leaks, I can then explore this leak information to understand those patterns and the response time that we're getting for leaks, because that's what we're interested in now. So let's have a look at the priorities by each one of these leaks on a chart. Again, the sum's not giving us very useful information, but if I now put that to the on average, we now are beginning to understand something interesting. Now for me, it was like, okay, there's a chart. For the engineers, this was their aha moment. This was then, they knew this. They were saying, we understand that the calls are not being prioritized correctly. But what they aren't able to do is tell their bosses that this is what's happening. And by actually seeing this within the data, they can then say, look, we know this is happening. So what we're seeing is that the calls, number of calls are going from 0.5 of a day to 7.5 days it takes them to respond to those calls, depending on the priority that it's given to that phone call. So they're responding very rapidly to the priority 1 phone calls. Makes sense. There's a big leak, get out there, fix it quickly. So they are responding as quickly as they can to those leaks. To the ones that are prioritized as a number 5, takes them about a week to respond to that. So they know that. But what we're finding is if we look into this data a little bit more, so we can go in and do a calculation on these. So these, when the engineers are sent out, they then do a record of what they see when they get to the site. So they've already had their call prioritized. They then respond to that leak. So this is their response data. So I'm going to go into the data table here. And you see that at each one of these leaks they go to, they estimate the amount of leak rate at that location. They also estimate the duration that that leak has been occurring. So you can already see not every time are they able to make an estimate, or they don't do it, but in some cases they do. So by using that piece of information, we can now calculate, and this is going to be an estimate because the engineers are estimating it, but oops. This is the amount of water loss that they think they're losing each one of these calls that they've responded to. Oops. So I could take the leak rate, multiply it by the duration. So this is going to be the amount of water loss at each one of these locations. Calculate that, so I get the results just where we have both of that information. And now you can see I have my estimated water loss. I can create my map. So we're missing some information in some locations, but now if I look at that estimated water loss by priority, I'm going to put that on a table. We're going to look at it by average. So now we're seeing where we have the information, the priority ones, essentially those emergency calls they're sent out to do as quickly as they can. If you remember, they're responding in about half a day. They're losing about 35,000, whatever it is, gallons of water for each one of those. The priority threes, to which they're taking about 5 days to respond to, look how much water they're losing. So actually, these are leaks that are more underground leaks. People aren't seeing them as a gushing water. When they go out, they're seeing that this has been happening over a long period of time. So what the actionable point we could pick out from a really very simple analysis here is that when the service call is received, the customer service needs to ask more questions. Did you see this leak yesterday? Did you just not call because it wasn't a very big leak? So by then reprioritizing these calls, they can respond much better and really save water, and save themselves a lot of money, which is ultimately our money, because they're going to be charging us for this water loss. So seeing that has helped answer the question of how they're prioritizing the calls. So let's go ahead and see these leaks within each one of these zones. So I can aggregate out the total amount of leaks by each one of my zones. So now I can see the total amount of leaks in each one of these locations. So yeah, we can pick out spatial patterns. So now we're seeing different locations have different amounts of leaks. I can drill down into that data, and this time I'm going to look to find answers. So rather than requiring you to know what it is, if you do know what you want to do, we have the spatial tools. We also have suggestions here, so let's see how that's distributed. And again, you'll see how we can use the histogram to pull out those areas where I see a large number of leaks in each one of those locations. But that's the numbers of leaks. That doesn't really tell the whole story, because where there's more lines, more pipes, there's going to be more leaks. That's what we would expect. So let's just double check that. Let's get the water lines, add that in. Now I can aggregate that to the same data set that I had before. And this time I want to add in some statistics. So I want to find the total length of each one of my water mains within each one of these areas. So now I'm calculating slightly different thing. We see a slightly different pattern between those two. So there's a lot of overlap, but it's not exactly the same. So now we could look at that data set and say, okay, so are they responding in the same way? So the total length of miles, we'll do that there. Total length of calls we've had, I'm doing that on the wrong data set, with the total number of lines. And if we look that on a scatter plot, we see, yes, there is a good relationship between those two. So that makes sense. The more water lines we have, the more leaks we're going to get. So that does tell us an interesting thing. That's what we would expect, and that's what we're seeing. And that's another interesting thing when we're doing analysis. We use visualizations a lot, and Flora's already alluded to how we can change the different map styles to see different things. When we start our analysis, we should always have a good idea of what we expect to see. We would never start an analysis blind because it can all lie. Our visualizations can lie, our statistics can lie. So you would start your process of understanding what you would expect, and when you don't see that, it's unlikely that you found something magical. Chances are something's gone wrong somewhere. So you start with that, and that's your sanity check. Go back, am I seeing what I would expect to see? Double check your processes, and sometimes that's where the iteration comes back in again. So we now see that we have that good relationship between the length of lines. I can, of course, now change my map to be a choropleth, because now I've normalized that data. So I've gone from it being point information at each account number. I've now aggregated that into my water zones. So now it's a choropleth. I'm working with information by area. I'm taking the area concept into account by taking into account the total number of lines. So I can now change that variable to be a rate, and then I can map that directly as a choropleth. So I could do that again by doing that calculation. So if I go into my data table, I'm just going to call that area, and I can do the length of miles times by the count of the number of complaints. I will get my new field, change that to a rate, and now I can visualize that as a choropleth. So now we see a slightly different pattern to the one we did before, because now we're taking into account the amount of water lines. So this is really showing us where we have an increased number of leaks, and we wouldn't expect it, because we've taken into account the amount of water lines that we have across those areas. So one last thing to show you is, let's have a look. The ages of the houses. So we would expect to see the same older houses to have more leaks because their infrastructure is actually failing. So we have that information of the housing in some data that's made available by the county. So that's residential parcels. So I can get that information joined into where I have my service requests, so where I know that there are leaks, by just aggregating that to my parcels. So now I can see the total number of leaks by each parcel level. And now I can look into that data that I had in the parcels one, and I can see the year built, and I can look at the total number of leaks that we have by house age. So let's drag this out a little bit so you can see it. So looking at the total number of leaks by each one of these housing dates, so when it was built, what we're doing here is we're really seeing the housing booms. So we're seeing when more houses were built in each year. If I change this to the average, we're seeing a totally different thing. We're actually seeing that the older houses, as we would expect, are on average making more phone calls about leaks within their house. That's exactly what we'd expect. We're not seeing any pattern in the modern houses. In fact, if anything, they've gone down a bit. Maybe we see a couple of years when they've come up a bit. But that's telling us what we'd expect. But what about those areas that we saw in the previous map? So we saw some areas did have slightly more leaks than other areas. One of the areas was down here. So I'm going to select that area, drag it across, and zoom in, effectively filter out the data so I'm just looking at that area. So now I want to see what the pattern is within this particular area. Oops. So I'm going to do exactly the same thing with the output from that filter. I'm going to look at the total number of calls about leaks. I'm going to look at the age of the house. I'm going to put that on a chart. Except I put it on a table. I'm going to put that on a chart. I'm going to look at the average. Now you see something coming out straight away. So they're relatively small numbers because I'm taking the average. But immediately we see houses built in 2007, houses built in 2010 have way over the average number of leaks. Now again, this is something the engineers said they hoped that we could find within this data. They felt that there were problems with the copper pipes in this area. But what they didn't know was where. They didn't know exactly what. They sort of knew that some of the new houses they were being called out to. And what they said, if you can find out the area, that's going to help us, because we can then prioritize those areas and go out and change the copper pipe in those areas. And that is exactly what we find. So we see that these are the copper pipes that were built in those, laid in those years for this housing estate that was built in 2007, these houses. And these are the copper pipes that they need to go out and double check to see where the errors are. So by doing this analysis using the charts and the maps, we could actually pull out what they felt was happening, prove to their bosses that they need to look a little bit at the service calls, and also find out the areas. So hone in on that places where they needed to go out and do the copper piping. Of course, the other thing is, all my analysis has been recorded. I can repeat this. I can look at it with different data sets. But then the other key thing, as Clint laid out at the start, it's about sharing your analysis. So in this way, I could share this analysis back to the White House Utility District. They can run it on further data. And of course, I could share all of the information into a story map so that I can share that with all their bosses and say, look, this is what we found. Just pick out the key visualizations to share that story and report back on the actionable points from analysis. Thanks.
Gosh, just like Peter on the family website would say, that's freaking awesome. You know, this is really cool. You know, one of the things that I want to point out in Linda's presentation that was really interesting is this 5-step process: pose a question, model it, interpret, decide, share, and communicate. Inevitably leads to new questions. And what you saw her doing was progressing through that process of actually doing a number of analyses to get to some conclusion that's pretty cool. So I'm going to turn it over here to Mark Harrower. He's a GIS designer at Esri, helps a lot on designing a lot of functions, including a lot of the work on smart mapping was Mark's initiative for the company over the past few years. So he works on a lot of interesting things, and we're going to have Mark kind of close it out and hopefully have a little bit of time for questions. So Mark.
Clint, do you know what monitor you want? You got it? Okay, great. Wonderful. Well, thanks everyone. I get to take this home. It's been great watching this work here because there are a couple themes that I'm trying to tie together for us. And one of the things that really struck me both in what we just saw and what we saw in the plenary was that there are no magic bullets in spatial analysis and in doing GIS. What you need is a suite of tools, and you need a flexible approach to thinking through problems visually and asking questions and seeing something and iterating on that. And the other thing that goes along with that is a system that's responsive. Linda didn't mention it, but at times she was working with 5 million points in a browser, and she was doing this live. And that kind of speed and performance is really critical because it reduces the friction to thinking, well, what if? What if I just filter by this? What if I just look on Wednesdays? What if I just look at readings before 9 a.m.? And if you're not sitting there and watching the system spin, you really are encouraged to explore and ask those questions, because a lot of this work requires iteration, as Flora was saying, and you need to have tools that you don't feel like you have to fight. The other thing that I was struck by here watching this work was that what we're seeing is there are no single best tools, but there are groups of things that work well together. So when you pair a map and a histogram or a map and a scatter plot together, it's great. Scatter plots are good on their own, maps are good on their own. But when they are linked and they're live and you can use one to drive the other, and when the color scheme, as Flora was showing us, is transferred to it, there's this synergy that's happening because you can think of both of them as both the interface and the answer. So you might work with the map as a way to formulate a question. the answer is shown on the scatter plot. Then you use the scatter plot to refine another question, and then that answer is shown on the map. And so this cyclical process of linked together, and that's why Insights was very much built around cards, and these ideas of these cards that can be stacked together and are used. The other thing that I would caution, and I think we've all probably fallen prey to this, is that when you learn a new tool or a new technique, it becomes your favorite tool and your favorite technique, and you want to use it for everything. I remember in grad school when I learned how to do regression, and I thought regression was the most amazing thing in the world, and everything became a regression problem to me. And I think what we see is you have to recognize that whether it's map animation, whether it's 3D, whether it's some new spatial technique, that these things have times when they're very useful and they're very powerful, but they're not, again, a magic bullet. They're not going to solve every problem for you. And sometimes what they may do is help you simply refine the question that you want to ask. And so just thinking about this, interactive visualization and analysis go hand in hand. Visualization is hot right now. If you've been paying attention to technology in the last 10 years, you know that glowy 3D spinny things on the web go viral. People love this stuff. They want to see little like glowy things that are flying around a globe. That stuff's great, but let me say this as a person who's devoted his life to visualization. It will never give you proof. It will give you ideas, it will lead you to ask questions, but watching little airplanes fly around a globe is not the same as actually doing analysis. And a lot of people miss that. And a lot of, I think, people who are outside of our field and our bosses say, we need more visualization, get some D3 going, we need some really cool glowy 3D stuff. Those aren't answers. They're really good at helping you ask questions and helping you maybe confirm your hypothesis, maybe understand the results, but you need to push back when people say, oh, well, it's right there on the map, I can see it. Our eyes are so easily misled by things that we see on maps. And as Flora showed, she can change the message of the map to say whatever she wants. And that's why backing that map up with analysis is so important. So they really go hand in hand. It's not either or. Smart defaults help. I mean, as Clint said, I worked a lot on smart mapping, and one of the things that we're trying to do there is look at your data and do as many intelligent things to set the initial parameters as we can. Things like class breaks, color ramps, opacity amounts, how color schemes harmonize with base maps. But there's a real limit to analysis. Someone asked me the question, they said, will there ever be an easy button for analysis? Will there ever just be a magic tell me? And in fact, the way they framed it was they said, would it ever get to a point where you could automatically mine and say, I found 5 interesting things in this data set that you didn't know? It's an interesting thought problem, but my sense is, and talking to my co-authors here, is that you always need to approach this, as we've already heard, you always need to approach this with an idea, with a hypothesis. Otherwise, you're just mining for the highest correlation. You're like, oh, I found a 0.9, it must be something significant, right? And so we don't want to go on a fishing exploration. We want to have a question that we think we can answer. Now, visualization can lead to asking a question you didn't even know you needed to ask. As Linda showed us today, there were some subtleties in that data that might not have been obvious had she not spent time playing with it, and then that can lead to questions. But my sense is there always has to be a human intellect behind the technology. There always has to be someone who's partnering with the technology to ask these questions. Here's a challenge for this room. How do we introduce these ideas and these techniques to a broader audience? I think a lot of us are comfortable with this. Certainly a lot of what we've seen has been in various forms over the last 25 years in GIS. How do we bring these ideas to a wider audience so they understand the power of GIS and they understand that it is more than mapping? And again, I'm saying that as a cartographer. Mapping is wonderful, but mapping is not sufficient. And so how do we bring this idea of doing something like emerging hotspot analysis to a larger audience and have people get excited about it? Is that blog posts? Is it videos? What do we do to communicate the value of this work to a larger audience? And what are those aha moments that we can share with people and say, this is why we do this work. This is why we need more than merely plotting points on a map. As we saw a lot in the plenary and today, time is a very important frontier for us. GIS has been very good at dealing with space, and we're getting better at dealing with time. And the reason why this matters is that people are interested in studying processes, not merely static states. I don't know how many of you saw Suzanne's demo of fraud transactions in the plenary. That wasn't merely she couldn't have seen that just by looking at the numbers. too large a data set. She couldn't have found fraud patterns by just mapping static states, like give me a snapshot of today or yesterday or give me an average of the last year. Nor could she have found it if she had just done time series analysis. She needed all three to really uncover. And it was this sort of multi-dimensional slicing and dicing that suddenly there's a process that things are coincident in time and in space and in attribute space. And that suddenly becomes a signature, a thing that you can extract. And so it's not, we're very comfortable with states. And so there's been a lot of great work done, especially on the team that these two fine folks work on, in thinking about how do we bring in the temporal component to our thinking. Because a single snapshot doesn't tell you enough. And that's, again, nothing new, but there's some also really good data sets that are emerging. As you noticed, Linda was saying she has incredibly deep temporal data in a lot of cases now. What do you do with that, right? And so we're very good at binning over space. We say, oh, I've got too many points to plot, well, I should make a choropleth. What is the equivalent in time? If you have too many time records, what does your gut tell you what to do? And so these methods that we use for both time and space are really important for getting things like trends. We also have some in ArcGIS Online. I don't have time to demo it, but the latest release in June came out with some really great temporal tools as part of smart mapping. So this is now, I think, the 4th or 5th iteration of smart mapping, and there's some really great ways that you can quickly visualize temporal data using the smart mapping. And just to give you some ideas here, you can use color to encode inspection date. You can also do bivariate maps where one symbol, like say the size of the symbol tells you one thing and the color or the transparency tells you the temporal information. So you can say, is there a relationship between X and Y? And you can start to ask that question visually. You can just superimpose information. The one down at the bottom is time and magnitude. And so the size is the number of migrants who have been lost, and the color represents the time. And so that's this pairing up of these things. What's interesting about this is a lot of people, when you say we've added time to smart mapping, they immediately assume we're talking animation. And I want to emphasize that sometimes these static depictions that summarize are actually more useful, because an animation is a lot to absorb cognitively. There's a lot that can go on. And a lot of people love them, right? They go, oh, that looked really cool. And then you ask them, well, what do you remember about it? And they're like, I don't know. It just looked really cool. And so being able to sort of summarize large amounts of data like this in a single snapshot is really great. So I encourage you to have a look. There's some really good blogs. There's a new story map that was created that these images come from. So if you want to dig into this, all of these are live. This is released in ArcGIS Online. Insights is coming later this year. It's really, really exciting. I hope you guys are as impressed with it as I am when I watched Linda do those demos. She's working with 5 million points in her browser and just instantly like changing the visualizations and asking questions. And it's great to see the charting working in Pro. That pairing of multiple windows in the Pro environment, I think, is a really powerful way to work. So I think it's a very exciting time for analysis and visualization. We are almost out of time, and I see how much time do we have for questions. A couple minutes. So maybe we can all come up here if we want. We're also happy to talk afterwards. Also, just a helpful tip, if you want to know more, I could have watched these two demo all day. If you want to know more, they've got a lot more material available online. So you can either reach us afterwards. There's great blog posts. Linda teaches courses. Flora, you do some teaching as well. Yeah, and so there's a lot of other ways to get more material than what we were able to show you today. So hopefully this was just a taste or a teaser of what we have available. So thank you. Yeah, we have a time for perhaps 2 or 3 questions.
How much is Insights going to be?
Well, Jack shared some good news there at the plenary. Does anyone remember what he said about Insights? Exactly. Free for folks with ELA. Yeah, which is actually a really big deal.
So you can't answer the question.
It will have a cost.
We don't know the price yet, but
We're not trying to be coy.
yeah, and we're probably the wrong people to ask anyway.
We just build it.
we duck when those questions get asked. Yeah.
So can we come and visit you on the islands there in the expo to understand how to manage better very large data sets that, you talk about having to drink too much coffee?
Yeah, absolutely. Yeah, you can talk to any of us on the islands. There's also probably some very good tech workshops on geoanalytics and geo-event data. So geoanalytics is something, if you have it fixed data, geo events as if it's data that's updated, observational data. But I can definitely recommend those workshops if you want to know more about that.
Yeah, I don't know about you, but I'll be at the island the rest of the day today and then teaching 4 spatial stats workshops tomorrow, if you're interested in learning more about that.
Although we're the fortunate folks who get to talk about this work, there's many, many dozens of people behind everything that you saw on the screen today. So we're not the only ones that you can talk to. We just happen to be the ones talking today. So if you see the Insights Island, go and talk to anyone there. They're going to tell you a lot more about this. Yeah.
Data sharing using story map. I was wondering if you can actually embed the final results
The question was, can you embed the final results of this analysis in a story map as a way to share it, to communicate? Absolutely. That's a huge part of the work that we're doing. This past 12 months, we've been able to embed 3D web scenes into story maps as a way to share those, and we're going to continue to do that. Our hope, and Linda may be able to speak more to this, is to be able to embed the individual cards from Insights into a story map, because you may not want to share your entire workflow. You may just want to share like that one scatter plot that really communicates the final result, and you want it more than just a static graphic. You want it as an interactive thing that you can poke on.
Yeah, absolutely. So that's what we're going to do. We're going to have it so you can either share the static ones if you don't want people to access anything, or you can share the interactive ones. We're going to do a one-click so you can drop it straight into a story map. And part of that is that then you can do a lot more changes, because, of course, sharing the story, you don't necessarily want to share the analysis as it looked. You're going to want to spend a bit more time putting in photographs, whatever. But we're going to make that process of putting it into the template just done, give you that time to make it nice.
So I wanted to just mention one thing. We saw a lot of analysis of vector data today, but these techniques and approaches also apply to raster and imagery. The new imagery book, the book you guys all received this week, has a companion website with 200 live links, and I would say, I don't know how many story maps, but there's dozens of story maps that are used to kind of communicate real world kind of scenarios, kind of authentic examples frankly from your guys' great work. So that's really interesting. And that I just want to tie that back to earlier Flora said, how do I explain to my mom what I do? Last year we gave every attendee a book called the ArcGIS book. It's actually a pretty good book to give to your family and friends to explain what you do, and it also has this really interesting companion website, so people without having to buy anything or get any kind of login can experience what GIS is about. So we're gonna continue to provide more of those kinds of tools for you to extend your reach with your community and your family and friends. Maybe one more question? Well, cool. Well, hey, thank you very much. Have a great conference.